Hello scholars, welcome to Limpid online tutorial. You came across this question in your UTME examination. Will you be able to solve it or will you skip the question? Alright, in this video we are going to demystify this question in such a way that if you see similar questions, you will trash the question, okay? I would want you to watch this video till the end. I wouldn't want you to skip or pass this video because this video is going to be of help to you. And also do well to like our videos, drop a comment in the comment section, and also subscribe to our YouTube channel. Well then, let's jump right into it. In this video, this question says, in the figure above, the work done by the force of 100 Newton inclined at an angle of 60 degrees to the object dragged horizontally to a distance of 8 meters is. Alright, if you check this question, you will see that an object is inclined at an angle 60 degrees to the horizontal. Okay, now there are things you need to note in this question. This is under work, energy and power. If you have read work, energy and power, you will encounter this question. Okay, but today, yeah, your problems are over so far this question is concerned. All right, we are going to talk about object inclined at an angle theta to the horizontal and also to the vertical. Alright, you're going to talk about a lot of cases JAMB can ask you question. Okay, now let's talk about case 1. Case 1 is when an object is inclined at an angle to the horizontal. Okay, if you look at it, you see there is a horizontal line, there is an inclined line. Which one is inclined? Look at this. When something is like this, that is inclination. It is inclined. Have you seen it? All right, then when you now put a horizontal line like this is inclined to the horizontal. The angle the angle between the angle between this line and this line, this is what? Horizontal. Do you understand what I just did now? Let me come again. When an angle is between an inclined line and what? A horizontal line, this is what? This is said to be an object inclined at an angle to the horizontal. Okay, and how can you resolve this? We are going to do, when you see something like this, how can you resolve it? Take note. When you see something like this, how can you resolve it? And there is f here, there is theta here, and there is f here, there is theta here, and there is distance here. The distance from, maybe the distance, yes, the two distance. How can you do this? So far this is talking about horizontal inclination. Okay, how are you going to do this? This is going to be what? F times cos theta times your s. F cos theta times your s. What is your cos theta? Why is it cos theta? Whenever you are resolving to the whenever you are resolving to the horizontal, this f is going to multiply, this your f is going to multiply this cos, this theta, and multiply the distance. Do you understand? Take note, this is horizontal component. Do you understand? This is only for horizontal, not vertical. Okay, so after this we're going to talk about the vertical. So let's talk about let's check this question. When you see something like this, what are you going to do? Okay, remember, when you see something like this, they ask you to find the work done. What are you going to do? You will see that there is 10 Newton, right? There is 10 Newton, there is 60 degrees, and there is 2 meters. What are you going to do? We are going to resolve. Remember our formula, this times this times this. Do you understand now? So what we are going to do here is work done. Work done is what? Your force times cos theta times your distance. Okay, so what is our force there? Work done, our force there is 10 times cos theta, cos 60, times what? What is our distance? Let's check our distance very well. Distance is 2 meters. Okay, so it's going to be what? Times 2. Okay, so this in total, what is our consistency? Consistency is 0.5 or 1 all over 2. Okay, therefore 10 times 1 all over 2 times 2. This will cancel this. This is going to be what? 10 joule. Okay, that is what? That is our answer. If you check this, you will see that 100 Newton is inclined at an angle to the horizontal, that's 60 degrees. Okay, so how can we solve this? Remember that they did not label the distance. Okay, if you check there, you will see that they gave us distance 8 meters in the question, but they did not label it. How are we going to do it? So let us draw our diagram. All right, if you check, this is what the question is talking about. Okay, so how are we going to do it? Don't mind the grammars, they are just telling us, okay, the blah 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 blah. This is just what the question is trying to tell us. So from the previous example I gave, you can solve this question, right? Yes, you can. This is going to be what? 100. This is going to be 100 times cos 60. Why is it cos? Because you are resolving to the what? You are resolving to the horizontal. Do you understand? 100 times cos 60 times your distance. Times this your distance. Do you understand now? So that is it. So let's solve. Your work done is going to be what? 100 times cos 60 times your 8. Are we there? So what is your cos 60? Your cos 60 is, this is going to be 100 times 1 all over 2 times 8. These two will cancel this 8. Okay, this is going to be what? We are now left with 4, right? Yes, 4 times 100 is going to give us 4 times 100 is going to give us what? 400 joule. Do you understand now? This is very simple and straightforward. That's all about horizontal component, but sometimes JAMB will give you vertical component. Okay, all right. What if this question is talking about vertical? Okay, inclined at an angle to the vertical. What if it's to the vertical? How can you do it? All right, let's recreate this. Remember that angle on a straight line is equal to what? 180 degrees. Yes, that means 90 plus 90, and perpendicular angle is said to be 90 degrees. What is perpendicular angle? This is our perpendicular angle. This is said to be our perpendicular angle. Have you seen it? That's your what? 90 degrees. Do you understand? So going back to what we have here, if half of this is 90 degrees, therefore we can divide it, right? So just follow me along, you will see something I'm trying to say. If here is 60 degrees, here will be 30 degrees. Do you understand where I am going to? If here is 60, here is going to be 30. Are you with me? Then if here is 60, here will be 30. We must make sure that it is 90 degrees. Do you understand me now? But in that question, if you look at it very well, here is 60 degrees. Okay? If you are to draw the diagram, if you are to draw the diagram fully, then include the vertical component and the horizontal component, what are you going to do? That means we are going to introduce this box. We are going to introduce this box. Have you seen it? If you introduce this box now, look at the box, look at this question. Look at the box. Have you seen it? Then if you check it, they did not include this line. They did not include it there. Okay, because we are only talking about horizontal components, therefore they are only concerned with this line and this line. Do you understand? They are not concerned with this line. Are we there? So what are we going to do now? For us to find the I'm trying to join both the vertical component and the horizontal component together. So in case they ask you to find the horizontal component, do you understand? Sorry, they ask to find the work done on an inclined plane at an angle 30 degrees to the horizontal, to the vertical, sorry. Okay, so once you're trying to find the work done, once you're trying to find the work done on an angle theta to the vertical, this is what you have to do. So this, therefore, this here is going to be what? So here is going to be what? Your 30 degrees. So if you are to resolve to the vertical, we are going to resolve this way. Do you understand? So resolving this way to the vertical, what will be your formula? Is going to be sine. The difference there is going to be sine only. Okay, the difference there is going to be sine only, nothing much. For vertical component, for horizontal component, is going to be cos. For vertical component, is going to be sine. So solving this question, if they gave us this question in vertical component, solving this question is going to be this format. Okay, look at it. Have you seen it? The first one was like this. Abi, the first one was like this, but that's the horizontal component, right? But now we are no longer concerned with the horizontal component, rather we are concerned with the what? The vertical component. That's this. Have you seen it? So let's solve our question. Hadimi, they asked us to find the angle on to find work done on an inclined plane. Okay, they asked us to find the work done on an inclined plane at an angle theta to the vertical, not to the horizontal. Okay, to the vertical. Hadimi, they asked us to find the work done, and the angle is to the vertical. This is going to be what? This is going to be work done is going to be 100 times sine 30 times 8 meters. Okay, do you understand me? Because what we are going to do there is 100 times sine 30, because you are resolving this way, sine 30 times your 8. Are we there? So that's how to do this. So but if it is horizontal, it's going to be 100 times cos 30 cos 60 times 80 times 8, sorry. That's it. So in that question, this is going to be what? 100 here is going to be what? Times 8. Okay, 100 times 1 over 2, 1 over 2 times 8. 100 times 1 over 2 times 8. Going to cancel these two, this is going to give me what? 4. Is still going to give me what? 400. Do you understand? So that's how to solve this question. I believe you understood everything about this question. Okay, first of all, 100 is going to multiply 60. If it is horizontal, it's going to be times 60 degrees. Okay, whenever you are resolving to the horizontal and the angle is between the vertical component, sorry, whenever you're resolving and the angle is between the horizontal line and this line, when the angle is between them, you are going to use cos. Take note. Do you understand? So when the angle now is between the vertical line and the inclined line, you are going to use sine. Do you understand? So that's all about this. Please, if you are watching us for the first time, do well to hit the subscribe button, share our videos, and also like. do what to drop your comment in the comment section. It is very, very important. Okay, see you in the next episode, right? Peace out.